Section 6.5, the law of cosines. We already went over the law of sines, and we said that it works, you can use it when you have angle, side angle, or side angle. But if you start with side angle side or side, then you can use the law of cosines. So the law of cosines basically says that any side squared equals the sum of the other two sides squared minus 2 times the other sides times the cosine of the angle. Not quite as easy to remember, but it's fairly easy to use to solve any triangle. A tunnel is being built through a mountain. To estimate the length of the tunnel, a surveyor makes the measurements shown in Figure 3. Use their data to approximate the length of the tunnel. So, I've actually often seen surveyors, county surveyors out on the streets and stuff like that, and they have their little tripod set up and they're looking off in the distance. This is what they're doing. Whatever the device is that they have, it measures the distance. They measure the angle in between, but then it calculates the distance of the object that they're measuring from far away. So we're given this angle over here. We are trying to find this length. So from our formula, c squared equals a squared plus b squared minus 2ab cosine c. So we're trying to solve for c. A is 388. It doesn't matter which one you call A or B. Plus 212 minus 2 times 388 times 212 times cosine of the angle 82.4. So now you just let the calculator do the work. 388 squared we could actually type this all in at once. 388 squared plus 212 squared minus, just put some parentheses around everything to make sure that it does it in the right order. 2 times 388 times 212 times cosine 82.4. And that's c squared, so take the square root of your answer. C equals 416.8. And that seems reasonable considering our other numbers. 416 seems like a reasonable distance. So the tunnel's going to be almost 417 feet. Alright, let's keep going. Now the only thing that we don't have is the angle. It asks us to find all the angles. Once we find 2, we can find the other one pretty easily. So now let's start with A. So that means we're going to do, I'll write out the formula in its basic form first. B squared plus C squared minus 2 BC sine the angle. Remember, these are the same 2 letters here and here. So a squared, 5 squared, I'll write out what they are. 25 equals 64 plus 144 minus 2 times 8 times 12. I'll leave that for the calculator. Times sine of the angle. Let's go ahead and write out what it's going to be to find b as well. So that's going to be 64, 8 squared, equals a squared plus c squared, minus 2 a and c. Oops. I wrote sine instead of cosine. Cosine b this time. So we can solve these. Again, we're going to let the calculator do most of the work. You can subtract 64 and 144 from 25. So we get negative 183. Divide that by the negative, whatever we get when we multiply together. 2 times 8 times 12. That we divide, we get 0.95. So we have cosine of A equals 0.95. And we need to do inverse cosine. 17.6. Same thing down here, 64. Add those together, that's 169, so minus 169. Divide that by negative 120. And multiply those all out. So we get cosine of b is 0.875. Inverse cosine, 28.95, so let's just say 29 degrees. -9 plus 17.6 is 46.6. Subtract that from 180. Angle C must be 133.4. Solve the triangle. We have an angle and the two sides that are not related. Since we have angle A, it's going to be cosine of A, so A squared equals B squared plus C squared minus 2BC cosine A. So we're solving for A. 10.5 squared plus 18 squared minus 2 times 10.5 times 18 times cosine of 46.5. It's a lot of work for the calculator. 10.5 squared plus 18 squared minus, and we'll do parentheses to make sure the calculator does the right order, 2 times 10.5 times 18 times cosine 46.5, 174.05, and we just need to take the square root of that. $13.2. And now that you have this side, we could actually set up a law of sines if you like that better. I know I do. We could do sine of 46.5 over 13.2 equals sine of b over 10.5 equals sine of c over 18. So just multiply by the 10.5, then divide by 13.2. $10.5 times sine 46.5 divided by 13.2. 0.577. We need the inverse sine of that. $35.24. But then you have to remember that we need to look at the supplement of that. So if we subtract that from 180, minus 35.2, 144.8, which we know that can't work with the angle that we know, because that's more than 180 degrees already. So you can eliminate it, which then we can find angle C. We don't need to use law of sines even, we just need to subtract 35.24 plus 46.5. Subtract that from 180. It's 98.26. And as a quick check, you can always make sure that the biggest angle is across from the biggest side. B is the smallest angle, it's across from the smallest side, and then A is middle angle, middle side. So related, I'm not going to show you how exactly, but related to the law of cosines is Heron's formula. It's a way to find the area of any triangle, and all you need to know is the semi-perimeter and each of the side lengths. So you don't need to know, it's no longer 1/2 base times height, which would be easier, but you need to know the height. Now you just need to know side lengths. So 1/2 A plus B plus C, A adding up all the sides to be the perimeter, half of that's called the semi-perimeter. And that's what's used here in the formula with all the side lengths. So let's use that to find the area of this triangle here, which is a lot of land. The streets, they just measure the lengths of the streets on each side, 125, 280, and 315. So first add those up. 315 plus 280 plus 125. So we're actually going to find the semi-perimeter, which is a perimeter over 2. $315 plus 280 plus 125. It's 720 divided by 2 is 360. And then our formula is square root of semi-perimeter times, and you subtract each thing. So 360 is going to be a part of each one. 360 minus A, 125. 360 minus B, 280. And 360 minus C, 315. So 360 times 360 minus 125 times 360 minus 280 times 360 minus 315, and we need the square root of that. $17,451. We'll include the 0.6. And then just to check to make sure that seems to make sense, if that appears to be about a right angle, so that should be pretty close to 1/2 of base times height. So we'll do 140 times 125. Pretty close. So yes, that does make sense. And since that's area and it's in feet, that would be feet squared, square feet.